What's up, everybody? I'm running out of time today. I'm gonna try to do as many of these integration by parts questions as we can. We'll see how many I get through. All right, let's see here. The integral of t sine 2t dt doesn't look all that hard. I see this t. That's gonna be my u sine 2t. du is equal to 1 dt, and my v is the integral of this. It's gonna have the 1/2 because of the chain rule, and the integral of sine is negative cosine 2t. Now that looks a little funky, so maybe I'll put parentheses on that. So now I need to multiply diagonal, negative 1/2 t cosine 2t, then multiply across inside of an integral. I've got this negative and this 1/2, which will come outside. That'll make it a plus, and that'll make it a 1/2. Then I've got 1, which doesn't really matter, and cosine 2t dt. Still need to do my integral here, so I've got, write this again, cosine 2t plus 1/2. The integral of cosine 2t is going to make another 1/2 because of the chain rule, and the integral of cosine is sine. Don't forget my plus c, make that look a little bit nicer. 1/2 t cosine 2t plus 1/4 sine 2t plus c. I think that's pretty good. Organize myself just a little bit more. All right. The integral of x squared cosine 3x dx, u is equal to x squared, and dv is equal to cosine 3x. Now I already noticed that these two are not going to mix. I'm going to have to basically degrade this 2 levels in order for this to go away, which means I'm going to have to do integration by parts twice. So let's do it. du is equal to 2x dx, v is equal to 1/3, and the integral of cosine is sine 3x. Multiply diagonally, that's going to be 1/3 x squared sine 1/3 x squared sine 3x minus the integral of these two. That's a 1/3 and that's a 2, so a 2/3 x sine 3x dx. Now I need to do the integral, but again, I already knew this, I'm going to have to do it again. U is equal to x, dv is equal to sine 3x, du is equal to dx, and v is equal to, the integral of sine is negative cosine, negative 1/3 cosine 3x. 1/3 x squared sine 3x minus 2/3 parentheses diagonal negative 1/3 x cosine 3x minus the integral of these two. Now I have that negative 1/3 cosine 3x dx. 1/3 x squared sine 3x minus, multiply these, positive 2/9 x cosine 3x. Make sure I distribute this, negative 2/9 times the integral of cosine 3x is going to be 1/3 sine 3x. We already did that. Plus c. I just need to multiply this 1/3 x squared sine 3x plus 2/9 x cosine 3x minus 2/27 sine 3x plus c. Yep, easy. The integral of arc sine of x dx. I kind of told you guys to skip this one. The way that these questions work is if you don't really know what to do, then the trick is that your dv is going to be 1 and your u is going to be the one thing that you have. So, you know, this is only one thing, but it's kind of like arc sine times 1, and the integral of 1 is an x. And basically the way this works is that the arc sine derivative turns into only x's and no more like transcendental functions. And so now these are going to work even though they didn't work before. So it's a strange thing. We didn't really get into it. It's not really all that interesting. As far as derivatives of these arc sines and arc, I only know 2 of them. I only know the derivative of sine and the derivative of tangent. So it's 1 over the square root of 1 minus x squared. I know that the tangent is 1 over no square root, 1 plus x squared. So here's my piece. Multiply diagonally here. That's going to be x arc sine of x, and then multiply across minus the integral of x over square root 1 minus x squared dx. Now I should be able to handle this, and I'm going to handle this with u substitution. Now this is not integration by parts. U is equal to 1 minus x squared, du is equal to negative 2x dx. And I'm going to divide that by the 2x. So then I'm going to have x arc sine of x minus the integral of x over the square root of u du over negative 2x. The x and the x are going to cancel out. I'm going to take this 2 and move it out front, but it's not a 2, it's a 1/2 because it's in the bottom. So I'm going to have x arc sine of x minus, but another minus makes plus 1/2 the integral of 1 over square root u du. We've done this a couple times. That's a u to the negative 1/2, and when we add 1, it's going to become positive 1/2, and when we divide by positive 1/2, it's going to be a 2. And so we've got x arc sine of x plus 1/2 2 square root of u. I'm just going to go ahead and put 1 minus x squared back in there. Don't forget my plus c. And I think that these 2 are going to cancel out, and I'm just going to erase. There we go. I think that's pretty good. Oh, it's behind my guy. There's our x arc sine of x, and there's our integral. Nice. Funky, but not too bad. All right, the integral of p5 ln of p dp. Now, a lot of times we need to basically wait for the x term to degrade. Like over here, we needed it to degrade twice. Now this is p5, so I'm thinking, do I need to do integration by parts 5 times? But no, because natural log, remember that is, we never ever want natural log to be the dv. So when I'm picking these, I want my natural log to be over here. That means that my p ends up being on this side. We like the natural log here because the derivative turns it into 1 over x. And the integral is going to be 1/6 p6. Add 1 and divide by it. Multiply diagonally 1/6 p6 natural log of p. p minus the integral of 1 over x, or I guess it should be 1 over p, sorry. 1 over p times this, okay, I've got the 1/6 that I can put out front. And then it's a 1 over p and a 6p. So I'm going to make it a 5p because it's 6 on the top, 1 on the bottom. That's going to make 5. dp, I need to do the integral of this, which is pretty easy. 1 over 6 p6 ln p minus this. We literally just did it before, so it's going to be 1 over 6 p power 6 plus c. 1 over 6 p power 6 ln p minus 1 over 36 p power 6 plus c. Not bad. The integral of x squared plus 1 e to the negative x dx. All right, let's do it. U is equal to, I guess, x squared plus 1, and dv is equal to e to the negative x, so v is equal to negative e to the negative x. du is equal to 2x. Again, probably going to have to do this one twice so that it will degrade enough to be easy to handle. So in for the long haul here, multiply these negative x squared plus 1 e to the negative x, multiply across. I've got a negative and a 2, so I'll make it a positive 2 x e to the negative x dx. And this is almost doable. U equals x, dv equals e to the negative x, v is equal to negative e to the negative x, u is equal to, du is equal to tx, x squared plus 1 e to the negative x plus 2. Diagonal is negative x e to the negative x, and across is going to be negative e to the negative x dx. Negative x squared plus 1 negative x. Oh, sorry. Knock at the door. What's up?
Hey guys, I got the line for football.
Sweet. 60?
Yeah.
All right, appreciate it. Grady just came by to pay me off for his grades. Let's see here. So multiply this. Try to jump back into the middle of an integration by parts question. Not the easiest thing ever. Distribute that and distribute that. Plus 2. The integral of this is going to be, we've done it a couple times, negative, I'm just going to use my eraser, negative e to the negative x. Now this is a plus c angle, but this is our first question where we have definite integrals. So I'm going to go ahead and now that I've done my integral, go ahead and set it this way. Now I'm a little bit nervous that I just jumped back in the middle of this question, so I know this part's right. Here's my 2. Take the diagonal pieces, go straight across. That negative made this a plus. Distribute it, negative. This one, the integral becomes negative. Okay. When we're doing these, and just, same thing, plug the 1 in, and then plug the 0 in. So let's plug in a 1. That's going to be negative 1 squared is 1, plus 1 is 2. E to the negative 1 is going to be an e on the bottom. Let's plug in a 1. Negative 2 times 1 times e to the negative 1, which is going to be an e on the bottom. Negative 2. Oh my god, I cannot believe this. Another person. Okay. Well, bring it to me if you got it. Oh. I just want to do integration by parts. Plug a 0 in. That's negative 0 plus 1 is 1. E to the negative 0 is going to be e to the 0, which is 1. So this should just be negative 1. But hold up. I need to subtract all of my 0 terms, which is going to be negative 1. Plug in a 0 here, and it's going to be negative 2 times 0. It's going to go away. Plug in a 0 here, and it's going to be negative 2 e to the 0, which is just negative 2. Don't forget these negatives and make sure you get them all right. So that's, look at that. It's pretty silly. Negative 6 over e plus 3. Okay. Common denominators, I guess, if you wanted to. Common denominators, 3e over e minus 6, if you wanted to. Doesn't matter. Keep going. Oh, this is one we did in class. The integral of the natural log of y square root y dy. And they're making us do it from 4 to 9. U dv natural log of y du is equal to 1 over y dy. V is u to the negative 1/2 power. That means v is 2 square root. Yes, y. Okay. Go diagonally, 2 square root y, natural log of y, minus the integral of 2 square root y over y dy. This is going to simplify to the same thing, y to the negative 1/2. Okay. 2 square root y, natural log y, minus 2. This is going to become 2 square root y. Again, this is from 4 to 9. This is a 4. I'm just going to use my eraser. Plug all this stuff in. 2 square root of 9 is 3. Natural log of 9 minus 4. Square root of 9 is 3 minus all of the 4 stuff. 2 times square root of 4 is 2. Natural log of 4 minus 4. Square root of 4 is 2. That's 6. Natural log of 9 minus 12 minus 4. Natural log of 4 minus plus 8. We could combine these because subtracting logs means divide. Honestly, that just seems like a horrible waste of my time. I do want to combine these two. So I would say 6 natural log of 9 minus 4 natural log of 4 minus 4. Making decent time. Hopefully we can get maybe through the first row of 8, maybe. The integral of x cubed cosine of x. Oh no. Dang. This is a triple. u is equal to x cubed, dv is equal to cosine x, v is equal to sine x, du is equal to 3x squared dx, x cubed sine x minus the integral of 3x squared sine x dx. U is equal to x squared, du is equal to 2x, dv is equal to sine x, and v is equal to negative cosine x. X cubed sine of x minus 3 diagonal negative x squared cosine x cross minus the integral of negative 2x cosine x, x cubed sine x minus 3. Let's multiply this. That's going to become positive 3x squared cosine x minus 6. The integral of this, oh no, last one, u is equal to x, du is equal to dx, dv is equal to cosine x, v is equal to sine x, x sine x minus the integral. Hold up. I think I just made this a little bit hairy. This should be negative 6 on all of this stuff. So this part needs the negative 6. This part also needs the negative 6. So I'll put positive 6 here. What if I do this? What if I just put all of this in parentheses? It's getting messy. This is a negative. Oh no. Alright. I got lost. Let's go back. Okay, this part is x cubed sine of x. This part is positive 3x squared cosine x. I need to distribute this part. And I also need to take the integral of this. So I'm just going to write it as negative 6 integral of x cosine x dx. I'm just going to pause for a second, do my distributing, and then stop. Now I'm going to do this integral. X cubed sine of x plus 3x squared cosine of x minus 6. Now I'm going to get x sine x minus the integral of sine x dx. X cubed sine x plus 3x squared cosine x, distribute this, minus 6x sine x, distribute this. That's going to be plus 6 integral of sine x dx. The integral of sine x is negative cosine x. So I'm just going to erase this and make it negative 6 cosine x. Now this question is freaking definite integrals as well. That's going to be a little bit of a headache. Oh my god, I got to plug all of this in. Whew. Alright, plug in the pi. Pi cubed times sine of pi, which is 0, plus 3 pi squared times cosine of pi, which is negative 1, minus 6 pi sine of pi, which is 0, minus 6 cosine of pi, which is negative 1. I'm going to multiply all of that times, subtract all of that from the 0 terms. Plug in a 0, 0. Plug in a 0, 0. Plug in a 0, 0. Plug in a 0. The cosine of 0 is 1. Minus 6. This is gone. This is gone. Okay, I've got negative 3 pi squared. And then I've got positive 6, and I've got positive 6. Negative 3 pi squared plus 12. Ooh, yikes. There will not be this hard on the test. One more. Ooh, it's going to be close. The bell's going to ring. The integral from 1 to square root 3 of the arctangent of 1 over x. Of course. So this is another one, right? There's only one thing here. So I'm going to set up the u as the arctangent of 1 over x. And I'm going to set up the dv as 1 so that the v is x. And my u of tangent, oh god, it's got that thing. Okay. Oof. This one's pretty gross. Tangent is 1 over 1 plus x squared. Except for I have this part here. And this part is 1 over x, which means that this needs to be 1 over x squared. And then I need to do the chain rule, and the chain rule of negative 1 is put the negative out front and subtract 1 to make it negative 2. So it would look like this. I need to simplify this. du. The top is a negative 1. I'm just going to do it like this. And the bottom is x squared. And that is just 1. Whoa, that was weird. All right. The integral from 1 to square root of 3. Oh, I don't need to do this anymore. X arctangent of 1 over x minus the integral of these two things. This is a minus, making it plus. That's an x on top and an x squared plus 1 on bottom dx. This looks pretty easy. This is u sub x squared plus 1 du is equal to 2x dx. Divide that here. X arctangent of 1 over x. This integral is going to become u on the bottom, x on the top, du, 2x on the bottom. The x's are going to go away. The 2 needs to come out front, but it's a 1/2. X arctangent of 1 over x plus 1/2. U on the bottom, we just did this. It was negative. Alright, let's put the negative here, and then a u squared on the bottom. And the u is x squared plus 1 squared. The integral of this is negative 1 over u squared. The negative is what made this into a negative. And the u squared is this part. And the 2 is coming from this 2. And the u is here. Okay? From 1 to square root 3. Arctangent is just like the inverse tangent. It's not all that hard to do. The square root of 3 And then when I plug this in here, the arctangent of 1 over square root 3 means what angle gives me square root 3 on the bottom? Square root 3 on the bottom is pi over 6 minus 1 over 2. Square root 3 squared is 3. 3 plus 1 is 4. 4 squared is 16. 3 square root is 3 plus 1 is 4 squared is 16. Okay, subtract away 1. 1. The arctangent of 1 is pi over 4. That's super easy. 1 plus 1 is 2 squared is 4. Okay, let's get all this right and get out of here. We've got, this is not getting any nicer. This is pi square root 3 over 6. This term is negative 1 over 32. And it is supposed to be negative. This term is negative pi over 4. We could maybe combine denominators, but I don't want to distribute this. This term is going to be positive 1 over 8. Probably do need to combine like terms there. This is going to be 4 over 32. That's going to become 3 over 32. Oh my God, wait a second. I made a mistake. Oh. I knew something was funky. The integral of 1 over u, not the derivative. Dang, amateur hour. Inverse tangent of 1 over x. The good news is the integral of 1 over u is easy. It's just the natural log of u, which is x squared plus 1. Okay, now let's plug these in. Pretty much the same thing. Square root 3, the arctangent, we already, okay, that's pi over 6. Plus 1/2. Square root of 3 squared is 3, plus 1 is 4. The natural log of 4. Minus 1, pi over 4, 1. 1 squared is 1, natural log of 2. Plus 1/2, natural log of 2. Well, we got the geometry kids breaking down the door. Pi square root 3 over 6 minus pi over 4. 1/2 natural log of 4. Ooh, we could even combine these natural logs if we were really gamers. Nope. Minus. Alright, this answer's a mess, and if I had more time, I would clean it up and make sure it was looking a little tight. I probably would combine these two things together by making, this 1/2 in here to square root of 4, which would be 2, and make this 1/2 inside here, and then I would combine them using, somehow I would combine these natural logs. I could even combine these with the denominator of 12. Is it worth my time? I don't know. We're done. How many questions did we do? 8? Not bad.